Good morning. I'm going to do something different this morning. In looking at the videos that I've created, I see that I'm so far away with my iPhone that you can't really see the apparatus that I'm dealing with. So instead of spending my time having you look at me, I'm going to try to concentrate on the apparatus that I'm using. So this morning I'm going to remind you of all of the things that we have used and let you see them on a close-up basis. First of all, we've been dealing with low voltages, in this case a 12-volt aircraft battery. These are the terminals. I've added copper wires as extensions so that I can place objects across these wires and create a circuit. So what I've done so far is I've used the battery, I've shown what a short circuit is, I've shown what a 12-volt battery can do, I've shown that the 12-volt battery is safe to touch. The voltage isn't high enough to send enough current through your body. I've pointed out to you what a voltmeter is, and this is what I didn't have, or my father didn't have, when he was trying to check batteries. I showed you the wire, the Romex wire, that's inside the wall of your house, and there's 3 leads or 3 wires inside there. 2 of them are insulated with some form of plastic covering, just like the outside here, and the center ground wire is uninsulated. The voltage is carried between these 2 terminals, and we'll talk about AC electricity in the next lesson. This is the baling wire that my father used when he would check a battery. I cut off a section. It's made out of iron. It has a fairly high resistance, but it is a conductor. It's important to know that all wires, or most wires, are covered with some form of non-conductor. A non-conductor is called an insulator. Usually it's some form of plastic, and this doesn't allow a short circuit when you wind it up into a coil. The wires inside the insulation stay separated. So I'm leading up to the point where I'm going to be talking about AC circuits, and so I wanted to mention some of the ideas that are important there. First of all, this is a bulb that works on AC. It's a bulb that works in your house. It screws into a socket, and I've attached these leads here so I can show you that 12 volts does not provide enough current for this bulb to light up. A little bit later, I will have a 110 volt AC system, and this bulb will work normally. Now, I'm going to start the topic of alternating current, and that forces us to go a little bit deeper into the world of physics. First of all, what is AC circuit? How do we create it? To understand that, we need to know something about the interaction between moving charges, electrons or positive charges, and a magnetic field. This is a magnet. This is the other half of that magnet. It's a fairly strong magnet, and to create alternating current, you need a magnet and you need moving charges and a wire. This is very exciting and interesting because here I have the other half of that magnet. I'm going to connect this wire that has alligator clips on the end and show you something very fascinating. There will be electrons moving through this wire, and there's a magnetic field around this magnet. Anytime there is relative motion between charges and magnetic fields, those charges are going to experience a force. Those charges are inside the wire and they try to jump out, and as a consequence, the wire will move. Watch this. See the wire jump out of the magnet? If that effect did not exist, we could not have AC electricity. In fact, what I'm showing you now is the motor effect. When we send current through a wire and the wire is in a magnetic field, the wire will move. The opposite happens if we send if we cause current to flow in the wire by moving mechanically, by moving the wire back and forth. Now, I do not have a galvanometer or anything that will detect the current, but when I move this wire back and forth, the electrons in the wire move back and forth as a result of the motion in the magnetic field. So to create a generator, I need an outside mechanical force to move a wire. To have a motor, I need a battery to cause current to flow through the wire, and the wire then jump out of the magnetic field. Okay, I'm going to quit for now. Take a look at this. Remember, you know what I look like. You know what my voice is. I'm hoping that you recognize that the stuff that I'm using here is all things that basically I find in my workshop, and they all demonstrate important aspects of physics. Okay, this is video number 4 on electricity.